Alright, so LeetCode 17, letter combinations of a phone number. It says solved I did it yesterday, but obviously I couldn't do this on my own. I had to understand this using a video. So yeah, I mean, here's it. So trying to implement what I understood while I solve this at the moment. So basic recursion question. Uh, I guess it's a Google level recursion one. It was asked in Google. So alright, so how we start is first of all creating a function. Yeah, creating a function in which we have array list as that has to be returned. So string type, naming it as pad. So basically this type of question in which we are forming combinations and like permutation and subsets or whatever, it's more like the pattern based question of either processed and unprocessed string. So we have two types of strings, that is processed and unprocessed. So what happens is we have a base case wherein the base case says that it's recording. Yep. So the base case is that if your unprocessed is empty, you stop. So if unprocessed is empty, we have to, what we have to do is, if unprocessed is empty, the unprocessed one is empty, then obviously the processed one is our answer. So string p is the answer. So what we do is we create a new array list, that is array list, string type, let's call it result, new array list, yeah, and then we add result dot add p, we add p in the result, and then we return the result. So this isn't the final thing that's going to happen. Further in the question we'll see that how the returning part is working. So after coming out of the base case, what do we have to do? We need to first of all make string, make an array, string type, call it mapping, in which we'll have to now put the values, like at index 0 it's nothing, at 1 it's nothing, at 2 it's ABC, so we need to assign them. So what we'll be doing is that we'll take these numbers as indexes, and then so for 0 we'll have an empty string, for 1 we'll have an empty string, for 2 we'll have ABC, for 3 we'll have DEF, 4 will have GHI, 5 will have JKL, 6 will have MNO, 7 will have EQRS, 8 will have DUV, and the 9 will have WXYZ. Yeah. Yep. So now what we'll be doing is that we'll need to figure out the digit part, obviously, because how do we, like, here we have 2 and 3, so we need the values of 2 and 3. So first of all, to get the values of 2 and 3, which we have right here, we need to access 2 and 3. So we can have int digit, int digit as, so 2 is like unprocessed basically right now, so unprocessed dot char at, it's at the first character 0 minus 0. Why do we do that? Because the char, it's char, we need int, so whatever the value of 2 is in ASCII, we'll subtract 0 from it, because obviously 0 plus whatever value of 2 was. So for example, if value of ASCII, value of 0 in ASCII is suppose 100, so value of 2 in ASCII will be 102. So if we subtract 100 from 102, we'll get 2, and that's the digit we need. So yeah, so we'll subtract 0, getting int digit. So now what we need to do is we need to figure out what we need. So for that, for 2 we need ABC. So what we'll be doing is that in order to get ABC, we'll have mapping and we'll put digit. So this gives us the letters, yeah. So this is basically a string, so yeah, it's gonna give us the letters. So we'll get this string of letters for 2, I would say, yeah. So now the main thing comes in. Alright, so yeah, that's the main thing. So we'll need to have an array list again to store the answer locally. See, the tree works of it in a way that first of all you have processed as empty and unprocessed as 2 and 3, 23. So now at every level you will be having what we call that as an array list, yeah. So initially if your processed is empty and unprocessed is having 23 as a string, so there you have an array list. Suppose we call it current, so there you have the current array list. Next level, we have 2 on this side, on the processed side, and 3 on the unprocessed side. So yeah, so for this recursion you have another one, yeah, and then another array list, and then for the last level in which you have elements of 3 combining with elements of 2, you have another array list. So yeah, we need to store the levels locally, so that initially when we combine all those array lists, they are being returned in the manner so that we get this as the complete answer. I mean, recursive tree would help in understanding what I'm talking about, but the basic is like, suppose here it's empty, here we have 23, so what goes down is 2 comma 3, yeah. So here we'll have a current, yeah, and then here we'll have a current, and then yeah. So now whatever value this is gonna give will be added to current for this particular level, yeah. So like, let's call it level 1, let's call it level 2, and let's call it level 3. So whenever our base case is missed, when this is not empty, Yeah, so wait, yeah. So whenever not processed comma slash unprocessed, yeah. So whenever we see that our base case isn't hitting, that is whenever our unprocessed is not empty, we will be forming uh, what do we say, let me just make that right here, array list string, let's call it answer. I mean, I named it current, so let's name it current. New yeah. So whenever we won't hit the base case, we will form a current array list, that's for sure. So yeah, here base case isn't hitting because our unprocessed is not empty. So yeah, we'll form this. Further, base case still not hitting, we'll form another current array list. And then when the base case hits exactly, so we will be adding all the answers we got from this combination, all the this thing to the current, and then that will be returned here and that will be returned here, initially making this as final current that is returned. So yeah, it's gonna contain everything inside of it. Like, let's go with that. So we have our digit, we have this, we have our array list. Now we'll have a for loop in which char ch will be will take individual char from letters dot to char array. Yeah, do I put that? Yeah, I guess I do. Letters dot to char array, in which when I take a character, what do? I in current I add all. Add all is used basically so that I just add the values, the elements, and not the complete list type or whatever it is. Here we have the list type, so yeah, I just want the values. So current dot add all. I'll call the recursive function. I'll call pad, in which I'll add the character to the processed part, so we'll get this sort of thing. So this is basically adding a right here. So in 2, like in 2 we have a b c. In 3 we have d e f. So in 2 we took a first, obviously the for loop works that way, and then we make sure that we go and process dot sub string, make it 1, yeah, and then we return current. So this is the ending point of the function, yeah, this return of current. We can have just pad, yeah, we'll call pad, in which in our processed we'll have it as empty and our unprocessed will be digits. Yeah, how about that? I have to comment that out. Alright, letter where return pad. Okay, Okay, so I need to handle this case as well. Wait, if uh, digits dot empty, p is empty, then we can simply return new array list. Yeah, alright, it works. Yep. So the flow of this question is, so I call pad right here. Yeah, it sees is up empty. It's not empty because it's having digits in it. That's 23. That's our case. Yeah, it's having 23. So it goes here, maps, takes the digit, that's 2. Yeah, and then because up to char at 0, that's 2. Gets 2 as a digit integer type. And then what happens is we get abc from this command, from this line of code. We get abc string, and then we create current. Now what happens is char ch takes letter a, adds it to this, and then yeah, here we have now a. As I said, here now we have a, and then we have b right here, because obviously up to also string, so from 1 till end is also 1. So yeah, 0 and 1, so this is 1, so it starts from here now, so it's on 3 now. So we check, is it empty? No, it's not empty. So yeah, first current made, obviously. Now second current will be made because it wasn't empty. So now we take, now the up is basically of the one element only, so at 0th index we'll have 3, so we'll get def from this. We'll make another current. This is level 2 current. Yeah, and at this level 2 current, what we'll be doing is char ch. Now from d, so when we add d to it, char ch is d at the moment. When we add d to it, this becomes empty. Yeah, this becomes empty. So when we call this with ad and empty, what happens is that result.add p, we create a result array list, we add p to it. Yeah, p is basically this whole thing, that's a and d in first case, ad. We add ad to result, we return result. So basically this return result is, you can just literally copy paste this return result in place of this. Alright, I mean not in place of this, but in place of this. So basically what's happening is current dot add all, and here in the selected area you can have return result. So what is return result gonna return? A and d, not a and d but ad, like this. Yeah, so it's gonna return that as is like array list. Alright, but we need just the element, that's why we use add all. So we add the element, that's ad, to current. Now the loop isn't over, we focus on e and then we focus on f, or in both the cases we'll hit the base case. We'll add to p, we'll create a result, we'll add p to it. Every time a new result has been created, we'll add p to it, that is now ae and then af. The return result, that's what we are returning right here, I mean the value. This return result is basically returning it's basically returning ae for the first case, af, and then ad in the first case, sorry, my bad. So ad, ae and af. It returns ad, ae and af, and put ad, ae and af as a list right here. Alright, imagine here you have a list having ad, it adds to current. imagine having a list here that only has AE. It adds to current. The element it's only, because add all makes sure it only adds the element. Imagine AF right here in a list, just AF in a single list. It adds AF only, not the list, only AF to current. Yeah. For loop ends. Now for loop ends. We return current. Fair enough. Now this current goes back to this level 1, wherein we had nothing sorted out for ourselves. The topmost current, wherein our processed was 0 and our unprocessed was having the digits 1 in it. So that's how the tree follows. You make tree, your left side is done, it returns, it goes back to the top. Now you focus on the right hand command. So then you focus on the right hand command, and yeah, then obviously you will have 2 again. Is that right? You'll have 2 again. Yeah, you'll have 2 again, but in this case you will have it with B. You had it with A, yeah, because at 2, when you take in 2, it's gonna have 3 arrows going down, A, B and C. So you did the A part, you went back to the top, you gave the current A, D, A, E and AF back to the top current. You came down, now you're gonna focus on the B part. It's gonna have 3 lines, obviously, because it's D, E and F. So yeah, obviously. So it's gonna go back to B. So whatever thing happened with the A case is gonna happen same. So here now we're gonna have B, D, B, E and B, F. Same for B and C. So same is gonna happen for them. It's gonna get added to the result. Yeah. So now the question is, we had 3 current. Yeah, we had 3 current. So every current when returned will go back to the level 1. Yeah. So this current dot add all was level 3. So here for first we'll have it for A. So all the 3 elements A, B and C are gonna hit level 3, and then they're gonna return at level 1, because that's how recursion works, that's how stacking works. So you start, you come at the bottom, you send it above, it goes for the another function call, it sends it above again. So that's how stacking works, because everything above is waiting. Until and unless A, B and C are not done, we won't be returning the current, obviously. So that's how current gets its length as 9, because it has 9 elements right here, 3 from each A, B and C. So every A, B and C, all these 3 will hit level 3 current. It's gonna send back to the top, and that's how we'll have the accumulation of all these AD, AE, AF, same for B, same for C. So yeah, that's how the recursion is gonna work. I wish I could have drawn the tree and everything, but I can't at the moment. So yeah, but that's how recursion is working here. So it's returning current. After A is executed with A, D, A, E and AF, it's gonna come out of the for loop, it's gonna return current. Now this return current is gonna go at level 1. So now initial current is having these 3 elements, length is 3. It's gonna go again in the for loop. Alright, after this return, it's gonna go again in the for loop, because we have B and C waiting for A to complete its recursive calls. Alright, here we had this thing. Yeah, so now this thing is gonna have for us, if we're gonna take 2 on the left hand side, on the process side, it's gonna give us A, B and C. So A is gonna now have to pair with D, E and F. So till the time A is done with D, E and F, everything comes back to A, it goes back to 2, and then 2 sends it for B. So that's how recursion is working. It's going back till the time A finishes, B and C are waiting. A finishes, sends its results to the top, it's in the current, all the elements are stored, AD, AE and AF. Now then we focus on B, C is waiting. B sends its results to the top, BD, BE and BF. Now C is gonna get executed, and then that's how C is gonna send its results to the top. So this return current is happening let's say 3 times here, because it's returning for all the values of a d, a e, and af, and then it's going to return, it's going to come back in the for loop. Now it's going to run the for loop for b, all right, and then it's going to run the for loop for c. So that's how it's working, and that's the basic of it. So at each level current has been made. So that was my attempt to make you understand, or make my approach more clear without having a tree at the moment. But yeah, you can try it on pen and paper. That's how it gets better. So yeah, that's it for this question.